This video is on a lesson. We're on igneous rocks. Here we see the research question: how does the cooling rate affect the size of the crystals formed? So the first thing you're going to do is you're going to make a prediction. So you're going to predict how the cooling rate will affect the crystal size. So I've written a sentence there. I think the largest crystals will form on the hot or cold slides. You should probably know that from the first task above. And then the next thing you're going to do is you're going to say this is because. So that's where you need to try and explain why the crystals are different sizes and why you think the bigger ones will form on the hot or the cold slides. Then we'll do the experiment. So here's the experiment. We have this is called salol. It's liquid at I think it's sets at 37 degrees, so it's been heated up and it's a liquid and it's currently cooling down and forming crystals. One of them is an insulated container and therefore it stays warm longer. One of them is just exposed to the air, so it's in 20 degrees, I think it is in here. And then the other one is in a container with some ice on it, so that it should cool down really quickly. So you decide which one, whether it will be in the hot or the cold, which one will form the biggest crystals, and pause the video now and complete your prediction. Good. Hopefully you've made a prediction and you've written it in your OneNote there. The next thing you're going to do is you're going to look at the results, and here are the results. Let me set this up so you can see them. This is our insulated one, and hopefully you can see. Let me try and get it to focus. You can see that it is in fact one large crystal. You can even see the lines in it as it was formed. Then here we have the ones formed at room temperature, and you can see that this isn't one large crystal, although there is a large one there. It comes with some smaller ones as well, where lots of crystals have formed at different points and grown. And then the final one is the ones that formed quickly because they were in ice, and you can see that that's lots of very small crystals. So what happened in the quick one is that the crystals start growing in multiple places, and they grow out and then they run out of space because there's a crystal near them that's growing. Imagine a flower bed or a plant pot, and you plant lots of plants in it. They're never going to be very big because they're all getting in each other's way. Whereas when it's cooled slowly, it's almost like you've planted one plant in the plant pot, and it can grow very big because it can take up all of the space. So that is that. The next thing I'm going to get you to do is, we have here a collection of rocks. I don't profess to be an expert on these, but we're going to have a look at them, and we're going to try and identify which ones we think are sedimentary, which ones are igneous, and which ones are metamorphic. I'm going to use a nail for this so that I can scratch it a little bit and observe what happens. So let's start with this first one, this big one here. So you can see it looks a little bit grainy, and the grains aren't shiny. And if I scratch it, hard to see on the video, if I scratch it, little bits are coming off it. So this one I believe is a sedimentary rock. Looks like some kind of sand that's been used to form it, so probably sandstone or something like that. So that is sedimentary. It's grainy, it's not crystals, and it scrapes off easily. Whereas if we look at this one, for example, we see similar sorts of things. There are bits within it, however, they are like crystal, and maybe if I tilt it down a bit more so you can see it up close. Oh, that's much better, isn't it? yeah, you can see that there's crystals in it. They don't break off easily because they've grown and they're kind of interlocked with each other. And that's the same sort of scenario that you see here with this one. So I believe those two are igneous. In fact, I think this one might be igneous, but we can see different crystals that have grown within it. Yeah, so those three are igneous. Crystals that all look like small grains, but they're crystalline grains. Then we have here another sedimentary rock, but this time formed with much bigger sediments. So we can see that they break off. You can see bits within it. You even see the label, it's number 26. That's not its name. So two sedimentary rocks. And then we're left with these ones. And these are very smooth to touch. Can't really scrape them. This is where it's been heated up. It's one of the other two that has been heated up and formed a metamorphic rock. This is actually, I think, slate, which forms underground as the volcano erupts. Some of the lava stays underground, forms an igneous rock, but then experiences heat and pressure and forms a metamorphic in nice layers like that. I believe that's how slate is formed. And we have similar here. This is another example of a metamorphic rock. You can see there's no real crystals. The crystals that are there clearly have like melted and become one big one and merged together, fused together. So that's a metamorphic rock. So those are the different types of rocks. If you're in class, then you can collect one of your own plates and you can have a look at them as well, and you can feel and touch them and try and sort them like I have done into 3 piles, and then see if someone else agrees with you about the 3 piles, igneous, sedimentary and metamorphic. And then the very last thing I want you to do is take a look at your own ones that you've been growing or that you made the other day. Remember, we made sedimentary rocks, and try and compare the difference. So remember, A, this is labelled at A, was all sand. Then we had sand and a bit of salt, sand and a bit of sugar, sand and cement, although this looks like just cement on top. And I want you to compare them and see what they look like. Again, you can use the nail if you need to scrape it a bit and see what you think. Very good.